Traditionally, roofs in this country are pitched. They can be covered in a variety of materials including slate, clay or concrete tiles, and even lead. Larger buildings, such as blocks of flats, often have flat roofs, where the roof structure and the nature of the covering is very different. The simplest of traditional roofs is the lean-to roof. It has a limited span and is most likely to be found forming rear extensions. Thousands of these were built at the end of the 19th century. The roof is built with sloping timbers known as rafters. They can be supported on wall plates, and it was usual practice to provide joists to form a ceiling. In some cases, the top of the timbers were built into the wall, but this gave little protection to the rafter ends, and damp penetration could lead to problems of rot. Some Victorian houses were built with double lean-to roofs, with a centre valley for drainage. These can cause some maintenance headaches. Simple lean-to roofs are only capable of limited spans, say 3 metres. Greater spans can be achieved by inclining pairs of rafters. This arrangement is known as a couple roof. The feet of the rafters are normally supported by timber wall plates. At the top, they're nailed to a ridge board, which prevents lateral movement and makes the roof easier to build. The rafters are traditionally fixed at 16-inch or 400mm centres. This is probably the most cost-effective arrangement of the timbers. Traditional or cut roofs are still built today, but they're expensive compared to their modern counterparts. They can require sophisticated carpentry joints. A scarf joint, for example, is traditionally used to lengthen timbers. The foot of the rafter should be notched over the wall plate and nailed to provide a good fixing. Notching also helps align the top of the rafters. The plate is usually bedded in mortar and strapped down to the wall. Strapping is not always required for traditional roofs, but is good practice and doesn't cost much. At the eaves, the exposed feet of the rafters are usually hidden and protected by a fascia board. Any gap below can be finished with a soffit board. The soffit is commonly supported by a simple timber framework, and the fascia, which supports the guttering, is nailed to the rafter ends. Vents for the roof space often form part of the soffit. Overhanging eaves help protect the wall below. The detailing can be attractive, but is expensive. However, in the long term, it helps prevent prolonged saturation, the cause of most brick defects. Flush eaves, where there's no soffit and the fascia is fixed tight against the wall, are cheaper but provide little weather protection. Traditional cut roofs are very versatile and can be adapted to suit almost any house design. They tend to be used nowadays for one-off prestigious developments, so you rarely see them on new, large housing estates. On this site, safety gear is not being worn, despite being good practice and in most cases a legal requirement. Any new roof needs to comply with building regulations. These contain, among other things, approved guidance on the size of roofing components for given spans and loadings. A roof could also comply with the regs in other ways, for example, if it was designed by structural calculations. Most timber is imported from Canada or Scandinavia. Homegrown timber grows too quickly in our warmer climate, producing a lower density material. Timber durability can also be enhanced by chemical treatment against rot and insect attack. A problem with simple couple roofs is that they tend to spread when loaded. A closed couple roof prevents this by tying the rafter feet with a ceiling joist. Closed coupled roofs are suitable for small houses with spans of up to about 4 metres. At greater spans, the ceiling joists tend to sag. They can be supported by an internal load-bearing wall or by a combination of binders and hangers suspended from the ridge. Simple closed couple roofs are not suitable for most houses. Even modest Victorian terraces will need roofs that can span well over 4 metres. Large spans require long rafters, and to prevent them deflecting, they would need to be of substantial depth. This is a heavy and expensive solution. A more cost-effective approach is to use purlins. The purlin is normally built into the gable or party walls and supports the rafters mid-span. There's usually one on each side of the roof. Where houses are fairly narrow, purlins can span from wall to wall. In wider houses, deeper purlins or some form of intermediate support will be required. One common method is to use diagonally opposed struts supported on an internal load-bearing wall. Although effective, these struts clutter up the roof space. Another option is to strut vertically. This requires a suitably positioned internal load-bearing wall. To distribute the load along the wall, it's good practice to provide a wall plate. The vast majority of houses built before the 1950s will have some form of purlin roof. Many will also have purlin strutting. In summary, let's look at a well-built traditional cut roof from the early 1900s. The rafters are supported mid-span by substantial purlins spanning about 6 metres between party walls. The purlin ends are supported on a brick corbel and partly built into the wall. Two pairs of diagonal struts support the purlin. These bear onto an internal load-bearing wall. A neat bird's mouth joint ensures a strong and stable connection between the strut and purlin. Additional struts run from the purlin to the party wall. Two large section horizontal ties provide rigidity in high winds. At the top of the roof there is a ridgeboard supported on corbels. Purlin roofs are still built today, but are not very common. On this site, the roof space is being used for accommodation, and the designer has incorporated steel purlins. A wall plate screwed to the top of the purlin provides a fixing for the notched rafter. Steel's high strength allows long spans and precludes the need for purlin strutting. In big old houses, internal walls were usually too far apart to provide intermediate support for the purlins. In other buildings, there were no internal walls at all. In these situations, trusses provided purlin support. Trusses can be found in a range of shapes and sizes. Their primary function is to support the purlin, but they also help tie the external walls where there are no ceiling joists. They were made from big, heavy timbers, often with bolted and strapped connections. One of the best places to see traditional roof trusses is in Britain's parish churches. At various times in Georgian and Victorian Britain, houses were built with parapet walls. Sometimes this was to emphasise the facade and reduce the visual impact of the roof. The construction is not as complicated as it looks. Typically, the rafters are birds-mouthed onto a wall plate. The ceiling ties provide support for the gutter, which was traditionally lined with lead. For durability and appearance, the parapet is finished with a coping. This Georgian roof is being renewed using traditional techniques. Softwood boarding is being laid to take the lead gutter. Lead working is a very skilled and arduous job, but done properly, lead can easily last 150 years. Mansard roofs are easy to spot because each roof face has two slopes. Two mansards side by side keep the overall height of the roof to a minimum. Their purpose is usually to provide accommodation within the roof space. They were very popular in the 18th and early 19th centuries, and there are some examples from the 20th century. Collar roofs were sometimes used to create an upper floor at minimum cost. It's similar in construction to a closed couple roof, but the tie or collar is part way up the slope. The higher the tie, the less effective it is at providing restraint. A good joint between the tie and the rafter is therefore essential. A dormer set just below the collar provides additional space, allows for vertical window openings, and can also be an architectural feature. Some roofs are hipped. The hip precludes the need for gable brickwork, but its construction is quite complex. The hipped end is constructed from a pair of hipped rafters which run to the corners of the wall. The cut rafters which run into the hip are known as jack rafters. The need for purlins and struts depends on the size of the roof. In the aftermath of World War II, traditional building materials were in short supply, and government restrictions limited the amount of timber which could be used in housing. The Trotter truss is a lightweight prefabricated version of the traditional truss. It was designed to reduce the amount of timber in the roof while still allowing big spans. The trusses support the purlins and were typically fixed at 1.8 metre centres, with common rafters and ceiling joists in between. No internal load-bearing walls were required. The popularity of Trotter trusses was relatively short-lived. Their success led to more prefabrication of roofing components and the eventual development in the 1960s of trussed rafters. Trussed rafters provide a lightweight and fast form of roof construction. They come in many shapes and sizes to suit almost any building. The design of a trussed rafter depends on a number of factors: span, shape and pitch of the roof, the position of load-bearing walls, the height, location and exposure of the building, the type and weight of roof coverings, and the overhang at the eaves. In practice, most trussed rafters are chemically treated to protect against rot and insect attack. In most parts of the country, this is not a building regulation requirement. However, in the southeast, the regs insist on treatment to prevent damage from house longhorn beetle. The first stage in truss manufacture is to translate the elevations and plans into a computer-generated model. From this, truss type, size and layout can be calculated and realised in 3 dimensions. Once the design is complete, cutting lists and production details for manufacture can be generated, as well as construction drawings for use on site. Although a trussed rafter roof looks complex, the principles are relatively straightforward. The rafters and ceiling joists are not dissimilar to a traditional roof. Both will sag under loading and self-weight. By adding internal compression and tension members, the truss becomes rigid and deflection is minimised. Good jointing between members is essential if the truss is to maintain its structural integrity. Nowadays, the most cost-effective method is to use nail plates. A number of companies produce trussed rafters using varying degrees of automation. Trussed rafters, despite their light weight, can produce a very strong roof structure, but they can easily be damaged, so good site practice is essential. For example, they should always be lifted onto the roof in their upright position to minimise stress on the plates. Bending the truss over the handrail can pull the nail plates out of the timber. One of the big advantages of trussed rafters is their ability to cover wide spans without the need for internal load-bearing walls. However, the finished roof will deflect slightly, so to avoid damage, partition walls must be built after the roof has been tiled. It's common practice to fix the trussed rafters before the gable ends are complete. This provides a template for the bricklayers. The first truss is fixed to the wall plate, plumbed and temporarily braced back to the scaffold to keep it upright. Once in position, the remaining trusses can be erected. On this site, the trusses are fixed in position by skew nailing through the nail plate, but this can cause damage. It's better practice to use special truss clips. Temporary bracing keeps the trusses upright and gives some stability to the unfinished structure. When all the trusses are in position, a series of braces have to be added to make the structure rigid and to resist loading. Longitudinal braces should be fixed at each inner node point. They hold the trussed rafters in the correct position and at the correct centres. Linking the trusses together forms a single structural unit. Braces should be formed typically in 25 by 100 mm softwood. Each brace should be positioned to butt joint the gable wall and should be nailed twice to every truss. Plasterboard, when correctly fixed to the ceiling, helps brace trussed rafters. Where omitted, say in a garage, or where the wind loads are high, diagonal bracing at ceiling level may be required. Diagonal bracing at rafter level is always required. It should be nailed to the wall plate and to the underside of every rafter. It's this brace which prevents racking and keeps the trusses vertical. The layout of the diagonal bracing depends on roof shape and size. There are a number of possible configurations. On this site, the gable ends were built after the roof structure. The gable end, although masonry, is actually quite vulnerable to wind loading and must therefore be strapped back to the roof structure. The number of straps and their position depends on the width and height of the gable. On steep roofs, straps are also required at ceiling level. Strapping down the wall plate prevents the roof lifting in very high winds. These straps are at 2-metre centres and should be at least 1 metre long. A big disadvantage with standard trussed rafters is the lack of usable space within the roof void. Attic trusses are designed to free up the roof space for accommodation. To provide adequate living space, the use of internal members is restricted, so deep-sectioned, heavy timbers are required. To achieve sufficient ceiling height, these trusses have to be big, so big in fact that they are often delivered in sections and bolted together on site. Trussed rafters are also ideal for large span buildings. 50 years or so ago, timber roof structures would have been prohibitively expensive for buildings of this size. It would have been much more common to find corrugated asbestos sheeting fixed to steel purlins and trusses. Modern timber trussed rafters are specifically designed for each job to produce a cost-effective, light but strong structure. Factory prefabrication improves quality control and reduces the amount of work on site. They're relatively fast to construct, and they don't require the sophisticated carpentry joints of complex traditional roofs.